Hello, we are Team 16 and I will introduce you about our machine learning project. We developed music mood tagging model based on multi-level classification using music feature data and pre-labeled data. So our project starts with problem defining. Nowadays, music tagging is important since new songs keep coming out. Also, it is impossible to explore those countless songs to find the right music you want. So this become our first motivation. And among the features of the music, we are motivated to deal with a subjective feature, mood, which cannot be easily extracted from sound waves. Based on our motivation, we set our goal in 4 steps. First, process the music data. Second, build a few models using CRNN and music CNN. Next, compare among those models. And lastly, conduct machine learning experiments. For the next part, I'll explain you about related works we are used in our project. We first plan to use 마그나타같은 audio data as the data set, which both mood tags and objective tags are provided. However, due to lack of storage, we decided to use another data set, Audionautics-free music data. There was designated text but no labeled data, so we manually created the labeled data. Next, for data processing, we use LiveLosa library to load an audio file as MPI file and PyDub library for audio segmentation. Lastly, we use two base models. First is CRNN, the combination of CNN and RNN. It extracts features of music through CNN and classifies them as RNN. Second is music CNN, and as you can imagine, it is pre-trained CNN for music audio tagging. You can refer to the figures here for more detailed structure of the model.
Now, I will explain the challenges we faced during the experiment and what solutions we came up with. First, pre-processing the data. We first tried to run training with the original dataset provided from the reference, but we had memory issues when trying all the data. So we first ran the code with 370 chunks of data with the ratio of 230 to 70 to 70. Then we tried to find a new dataset and see if the code can be trained with another source of data too. We got 300 songs from Audionautics dataset and parsed into 29 seconds. There were information tags for each data, but no labeled data, so we made it manually using CSV and NumPy. However, 300 data chunks were relatively small, so we parsed the next 29 seconds of each song to enlarge the data. To extend the dataset even more, we utilized FMA dataset and conducted manual tagging, but it was not used in the final training. For the Audionautics dataset, there were repeated or unused tags, so we adjusted the tag data too. Next, we modified and tuned the architecture and hyperparameters of the model. I will only briefly cover this part. For CRNN, we changed the RNN layer option and even added some more layers, but there was no big difference. We increased the MEL spectrogram bands to generate and double the number of features in the hidden state to gradually improve the performance. For music CNN, we experimented with different activation functions, number of backend channel, and layers. Commonly, we changed the optimizer and reduced the dropout rates and tried different learning rates and etc. You can find out our code in this link if you're interested in our model structure. Lastly, to evaluate the performance, we use accuracy, precision, recall, and F1 score, mainly comparing F1 score and the accuracy. We repeated this training, testing, modifying process on and on based on these matrices.
From now on, I'm gonna explain about the result and analysis about our project. First, let's listen to the song Sunday Spirit from the audio and analytics data and think about which mood tag you think it is. Well, when we split this music into 29-second chunks and make the CRNN model to predict which tag it corresponds to was as follows in the graph. The model says the mood of this music is likely to be upbeat, bright, driving, bouncy, and so on. Here it seems to suggest enoughly sound and reasonable mood for the most part. With 836 number of audio and OTIC source music with 30 tag dataset that we manually refined and organized, we trained each of the CRNN and music CNN models by splitting original audio data into 29 seconds and 3 seconds respectively. At this time, we can consider the 29-second splitting as sum level training and 3-second splitting as instance level training. The resulting loss and accuracy related scores are as follows in the table, and let's look into these figures more deeply in the next slide. Comparing CRNN models trained on data of different lengths, one with 29-second chunks had much better accuracy and F1 score than the other one with 3-second chunks. On the other hand, music CNN model showed opposite result to CRNN. One with 29-second chunks has slightly smaller accuracy and quite smaller F1 score than the other one with 3-second chunks. Comparing CRNN and music CNN was also worthwhile. When it comes to sum level training, CRNN showed better performance in both perspective of accuracy and F1 score. However, when it comes to instance level, music CNN showed better performance. These are the references of our project, and thank you for your listening. This has been Team 16's presentation.